Today we're going to continue to look at section 7.1. Today we are going to be applying theorems about exterior angles and midlines of triangles. So here is our exterior angle theorem. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. Okay, so here I have a picture. I'm going to label this triangle ABC, where notice that at angle A, it has extended to something that is outside of the triangle. I'm going to call that angle 1. So essentially, angle 1 is an exterior angle. So it's saying that the measure of angle 1 is going to equal the sum of the measures of the remote interior angles. Well, interior angles would be angles that are inside of the triangle. When it says the word remote, it means that it's talking about angle B and angle C. It's talking about the two angles that are not right next to it. So since the measure of angle BAC, this angle right here, is right next to angle 1, those are just supplementary angles. So they have their own relationship. But the remote interior angles are the two angles that are away from angle 1. So that would be angle B and angle C. So I add them together, their sum equals that exterior angle. So let's use that information. Let's find the measure of the exterior angle. So we have angle 1, which is what I want to find. And notice that the two angles that are given are the remote angles that I'm looking at. So I know that the measure of angle 1 is going to be me adding those two angles together. So 55 plus 50 is going to get me the measure that I'm looking for. Add them up, I get an 105-degree angle, which is that exterior angle. Let's take a look at this one. It says find the measure of angle ABC. So notice that I want to find the measure of an angle that doesn't have an expression. But the expressions of the angles that I do have, well, the 3x plus 50 is that exterior angle. That equals the sum of the remote interior angles. So 2x plus 3x plus 10. Okay, so let's solve for x. Can't do anything on the left, but on the right I can combine like terms. 2x and 3x is 5x. I'm going to start combining my like terms, so I'm going to move the 3x over to the other side. That gives me 2x plus 10 on the right. I'm going to subtract 10. That gives me then 40 to equal 2x. And then finally, I'll divide both sides by 2, and I'll get x to be 20. Now, that's not my final answer. What I need to do now is I have several different ways in order to go about finding the measure of the angle that I'm looking for. One of them is the fact that I mentioned we have a relationship between the exterior angle and that interior angle right next to it. They are supplementary. So I would suggest that we maybe find the measure of that exterior angle. I'm going to substitute in the 20. So we'll have 3 times 20 plus 50. Well, 3 times 20 is 60. 60 and 50 give us 110. So that's a 110-degree angle. So the measure of angle ABC, I can then take 180 minus 110, and so that tells us that we have a 70-degree angle. So that's one thing. The other way that I could have gone about this, although it might have taken a little bit longer and you might have had a greater chance of making an error, is I could have substituted in the 20 into both of those angles, and then 3 angles of a triangle add to 180, and so then I could have found the angle by subtracting those two away from 180. Okay, but it'd probably be faster if you just start with that exterior angle and know that it's supplementary to the interior angle. Here is our midline theorem. It says a segment joining the midpoints of two sides of a triangle is parallel to the third side, and its length is 1/2 the length of the third side. So here's a picture. I'm going to label this triangle. We've got A, B, C on the left, and we've got D, E on the right. Okay, so we've got actually two different triangles in this picture. We've got the triangle ABE on the top, and then we've got the really big triangle ACD. So here's what's given based off of this theorem. So it says that we have midpoints on two sides of the triangle. So I'm telling you that in this, B and E are midpoints. Okay, so I need to have that information in order to understand this theorem. So if B is a midpoint, that means that AB and BC are congruent segments. If E is a midpoint, that means that AE and ED are congruent. But notice that not all four are congruent. We have two different sets of congruent pieces. So with that given information, there are two things that we can conclude. The first thing that we can conclude is that we have parallel lines. Those third sets of lines are parallel. So in this case, that would be that the segment BE is parallel to the segment CD. So if I have two midpoints that are connected together to form that segment BE, well then I can conclude that those two lines, BE and CD, are never going to intersect. They are parallel. The other thing this theorem tells me that I can conclude is that the length of BE is going to be half the length of CD. So CD is the longer length because it's a part of the bigger triangle. Take half of it and you have the length of the segment that is inside this triangle. So let's use that information and let's take a look at this example. So notice that in this picture, they are telling me that I have parallel lines. That actually is not technically going to matter in this case, because what I really need to look at is what's marked in the picture. Notice that X is a midpoint because UX and XV are congruent. Y is a midpoint because WY and YV are congruent. So because I have two midpoints and here I'm trying to find the length of a segment, well, notice that the segment that I'm trying to find is the segment that's inside the triangle. So that is going to be the smaller side. That, based off of the second conclusion that I just talked about, is going to be half of the side that it's parallel to. So it's really going to be then in this case, half of 6. Well, half of 6 is going to give me 3, so 3 is my answer. Okay, in this it says M and N are midpoints. So if N is a midpoint, that means BN and NC are congruent. If M is a midpoint, then BM and MA are congruent. It wants us to find X and Y. So let's start with Y. Notice that the two expressions that deal with Y are the two expressions that I know are going to be congruent because M is a midpoint. Congruent means equals, so 3y minus 8 is going to equal 2 times the quantity y plus 1. I'm going to distribute the 2 to get rid of the parentheses. That gives me 2y plus 2. I'm going to subtract 2y over to the other side. So now y minus 8 equals 2. And then I'm going to add 8. So one of my answers, y equals 10. Now I just need to find X. Notice that the two expressions with X are dealing with those third sets of the sides of the triangle. And because I have midpoints, I know that these are parallel lines. And I also know that NM, which is inside, is going to be half of CA, which is that longer outside segment. So NM is represented as X plus 5. That's going to equal half of the expression of CA. So I have to put 3x plus 10 in parentheses. Okay, there's a couple different ways you can go ahead to get rid of the 1/2. You could distribute it, or another way, because if I distribute, I'm not going to get a nice pretty number because 1/2 times 3 is going to be a decimal. So if you want, I can get rid of the fraction by multiplying by the reciprocal. So if I multiply by 2 on the right, that means the whole entire left side is also going to get multiplied by 2. So that gets rid of the 1/2. And then that gives us then 2 getting distributed on the left. So it's now 2x plus 10. And on the right side, it's just what we had in parentheses, 3x plus 10. So I'm going to subtract 2x to get the x's together. So 10 is going to equal x plus 10. I'm going to subtract 10. So it looks like we get x to equal 0. And hopefully that makes sense. If I was to plug in 0 for x's, notice that that would give this NM a length of 5, and it would give CA a length of 10. 5 is half of 10. So that makes sense. So that is us applying theorems dealing with exterior angles and midlines of triangles.